Hello and welcome to this video where we will be doing a very exciting blue teaming lab. This lab is called Investigate Investigate a Ransomware Attack in AWS using Splunk. So we are going to be getting down and dirty with Splunk. They have already deployed Splunk for us, as you can see. So all we need to do in order to get started is to download the VPN file, as I've already done. And then we simply utilize the VPN file on whichever host we are going to use Splunk on. For me, I have Splunk open right here. And that's because I downloaded the VPN onto my Pwned Cloud OS. And then I activated it right here, as you can see. Just simply through, using nano, copy pasting the VPN file, and then sudo open VPN pwnedlabs.ovpn is what I called it. You can get Pwned Cloud OS for free on the Pwned Labs website. So after that, we get into the Splunk, and we already have access as admin. So there are no credentials to log in. And basically what we're going to be doing is most of our work is going to be conducting search and reporting over here. And we're going to be trying to create a timeline, figure out what exactly happened in a sort of incident response format and research mentality in order to figure out what happened to our company here when the attacker attacked, how they attacked, what they did, and how they conducted their ransomware. So I'm just going to let this load. All right, so here we are. It's done and loaded, and now we are able to search through the logs using these queries that we're going to place here. So the first query that we're going to use is just a quick query specifying the index, which I have here ready for us. And by the way, I'll be using my commands here. However, you can reach all of these commands if you go to the official lab guide on the lab page for this video. So just utilizing the index's name, we're going to get a bunch of results. However, we do need to change the time from last 20 hours to all time. So once we change it to all time, we should be getting all the results. So this is a lot of results. However, one more thing that we want to do before we get deep into this and deep into the logs is that we want to modify the fields that we can see in the logs. Now, by default, there are some fields that are not checked off. Now I'm going to go through these one by one. So I have them all here. I'm going to go through them one by one with you so you can check them off with me. So firstly, AWS region. Now, as you can see here, I've already checked this one off. However, for you, it may not be checked off. And then event name. Again, I checked it off. And if you can't find it here, you simply go to the search filter. And for example, we search event name. And we'll get event name, and then we can check it off with this box. Make sure there's a check mark on it. And we do that for the rest of them. Like, for example, it's very valuable for us to see source IP address, to see which IP the user is calling from or making the API calls from. The user agent will tell us whether or not that person is using the CLI or is using a browser, what the browser is, or whether or not they're spoofing, whether or not they're, making custom user agents to get away with things. All of that will give us more and more details and more information to work with as we go through this incident response process. And lastly, we have the access key ID, which will tell us which access key the attacker has compromised or is using to conduct his commands or attacks, the ARN, the user identity type, whether or not it's a role or a user or what kind of identity it is, and the username, which gives us just a clear text username of the role or user that is being compromised or being used to attack us with ransomware. All right, now with these fields being done and making sure we have checked off all of these fields here, let's go ahead and get into the logs. Now, the first thing we're going to do is let's go ahead and analyze just common ransomware behavior to see what's going on and to see what may have happened. So let's utilize this command over here. And we'll run this. Again, this command can be also found in the lab guide. All right, let's see. Okay, so right off the bat, we see a few odd events by admin test. Now, admin test has been confirmed to not have been created by the actual administrators. Thus, admin test is a user that we've been notified by the IT team to be completely out of the blue. So this is potentially a part of the attacker's attempt to gain persistence, is to create this admin test user. However, we see that they conducted a few actions with admin test. Right here, we see detach volume and terminate instances. So possibly they did some destructive actions against EC2 instances where they detached the volumes, may have possibly just outright terminated and deleted the instances, and then kept those volumes for ransom, or it re-encrypted them, as we'll see later in this video, re-encrypted them and then reattached them as encrypted EBS volumes. So let's see what else admin tests seem to do. So if we search the user identity username, we'll get all of the admin test actions over here in this specific query. We see that he put objects and run instances. So he stopped instances and then he ran them again. And we also have something interesting here, which is a ransom note put object. So we're dealing with an S3 bucket potentially, and he seems to have put a put object as a ransom note. So let's go ahead and click this and dig a little bit deeper. If we click on this and click view events, we'll go into the details of this event. And as you can see here, if we go into the request parameters, we'll see that this is in fact a S3 bucket called ransom note. Now, the attacker probably made this bucket in order to place a note here, as you can see here, ransom note.txt with this hash. And this text file probably gave them instructions as to how they can get out of this ransom and possibly pay the ransomware attackers whatever they want in order to gain back their locked out resources. Now, we'll get into the locked out resources, but by the way, I want to mention that this hash could actually be the flag as per the instructions of the lab. So let's go ahead and submit this flag before we move on. I wonder if it's just like this. Yeah, there we go. Congrats, we have successfully completed the lab. Now, please don't leave because there's a little bit more to be covered here in this lab. And we're going to get into a lot of more kind of areas of investigation. And so we can get familiar with Splunk and how to detect ransomware on in our AWS environments. All right, so next, let's go ahead and see what this admin test account is all about. Now, like I said, this is sure to be a form of persistence. So let's go ahead and check any create user events or any sort of events leading us to or indicating how or when this user was created. Amazing. So as you can see here, it seems like John was the culprit. Now, John is probably completely innocent, yet the attacker used John's account in order to create this admin test persistent user. Now, as you can see here in the timeline, if we use this event time column right here to see the timeline of events in a proper order, we can see that firstly, John creates a user, which is admin test, if I'm not mistaken. Let's go ahead and check the info of this event. In the request parameters, yeah, we see admin test being created by John. And then we see that John also attaches a user policy to admin test, probably, which is administrator access. So John makes admin test, and then he gives him admin, and then this admin test goes ahead as admin test, creates an access key. So if you want to confirm, you can go to the event details. We see in the request parameters, admin test created a access key for himself. Now, this is quite a basic and a common method of gaining persistence. Possibly, admin test or the attacker did not want John to be too suspicious as a user in the environment, so he created admin test just in case his behavior gets caught. He can go back to John and make another form of persistence that way. And possibly he could also be worried that John himself can be modified by any cycling of credentials, any rotations, etc. So he doesn't want to compromise his form of his initial access user, which is John. So he goes and creates admin test. Now, one other thing to note is that this was done on Mozilla, Macintosh, Intel, Apple WebKit. This is a user agent specifically for a browser. So unless this is, going through some sort of proxy in order to deceive us, the attacker up until now is still using the browser. Amazing. So let's go back to our playbook over here and see what's up next. So let's trace back John's activity since he's the one that's been compromised in order to create this persistence. Let's see when the attacker compromised him or how it happened. Wow. So John was really used to gain situational awareness. Now let's go to the event time again and see what happened from the ground up. Okay. So firstly, we have get caller identity. Now, this is very clearly the initial point of the compromise. With get caller identity, it's basically, if you're not familiar, the who am I of AWS. So right off the bat, once he gets access to John, he says, who am I? And what is my identity in order to continue enumeration. And this has happened at this time right here. So if we were trying to create or produce any timeline, this would be our best bet as a starting point. So after he does this, he lists the attached user policies, which is probably for John, and he wants to see what policies he has access over in order to see what he can do and how he can navigate from there on. So if we go to the view events of this, to the request parameters, as you can see, he got the policies of himself in order to gain self-awareness and in order to gain situational awareness. and in order to know what he can do to the environment and how he needs to proceed. Okay, so after that, he gets the policy version. So he's looking deeper into his own policies, listing not only the listing more policies, but not only the user policies, but also the managed policies. And getting both policies, digging deeper and enumerating the policies that he has access over. And finally, he creates a user. So after he realizes, hey, I'm John, I have, quite a bit of access as John. What's the easiest, simplest, quickest way to gain persistence on this compromised user? And he goes ahead and thinks, well, I just simply create a new user. So that's what he did here. After some situational awareness, he goes ahead and creates a user, which is likely admin test. Yeah, admin test was created at this time. Amazing. So after that, he created a login profile, probably for admin test, and then he proceeds to continue the attack on browser. So up until now, we see zero tooling, zero Pacu, zero sort of any enumeration tools like CloudFox being used. The man is simply using browser to conduct these attacks and to move forward with his persistence. So if we wanted to confirm, we go to the view events and get the details of this. And as we'll see here, this was created for admin test. So he created a login profile for admin test so that he can log in on the browser. All right, let's go ahead and move forward. Now let's go ahead and trace back admin test's activities. So if we wanted to gain the activities of admin test, we can use this query, specifying admin test as the username, and specifying the table as all the fields that we want. Okay. Let's go ahead and again organize by time. So we see that the first thing that admin test does is log in the console, confirming that he's hacking through standard console actions. And then he's just simply accessing the console. So you'll see all these APIs go off, listing the applications, describing the regions. Now let's go back and see some more of what he did. So one interesting thing to note is that admin test, the attacker actually decides to delete John. Now, this might seem confusing at first, but let's go ahead and confirm that it's John. So we see the event name, delete user. And if we go to see the request parameters, we'll see John. Now, this might seem a little bit confusing. However, the reason why admin test deletes John is that this is not a prolonged engagement. This is not an engagement where the attacker simply wants to stay covert within the environment and use it stealthily in order to run things like Bitcoin miners or Bitminers, or use it to attack other companies or partnered companies, or use it to attack customers through this company. No. This attacker is getting very aggressive in his approach to this attack. He wants to completely lock out the company from all of its resources on AWS and then get money for it as ransom. So he goes and locks out John, gets things serious right on the spot, and makes it quite clear to John and to the team in charge that he's here to lock them out, and he wants money for their resources if they ever want it back. By the way, we can confirm again that this action and the actions of the attacker are being done on the browser up until now by the user agent. Okay, so up until now, he's been using the browser. However, let's see when or if this attacker, as admin test, goes back to use the AWS CLI to conduct his attacks. Let's go ahead and see. If we see the fact that the user created an access key for himself, that means that he may have used those access keys in the CLI. So this could be a great indication of when the attacker went on to use the CLI. As you can see here, admin test creates an access key for himself. And if we go here, we can confirm that the access key was in fact for himself, admin test. So this may be a good indication of when he achieved CLI access in order for him to, utilize whatever tools he wants to use. So KMS is often used by attackers in order to conduct these ransomware attacks. Now, if you're unfamiliar, KMS can be used to encrypt, decrypt, and re-encrypt resources on AWS. So if the attacker got admin access, he could potentially re-encrypt all of the resources using his own KMS key that only he has access to, and then charge the company in order for them to gain that KMS access. So let's go ahead and check the KMS activity on this user for admin test. Bingo. So this user created a key, and then shortly after, as you can see, created a key, and then shortly after imported his own key material into the key. So this proves that that the attacker did in fact use, or is in fact using, KMS in order to conduct this ransomware attack. So let's take note of the KMS that's being used in order to confirm it throughout the rest of our investigation that he is using this this new key. Oh, okay, here it is. So let's take note of this KMS key and copying it over here. Oh, sorry. Give me a minute while my network is finished fixing. All right, we are back and up and running. So let me go ahead and oh no, I spoke too soon. There we go. Okay, so let me go ahead and post this over here, because we are going to confirm that the user is in fact using this KMS key in order to continuously re-encrypt the resources and re-encrypt the things that he wants to lock out the company from. And also, if we go back here to create key. And we go to view events. We can also get the information here that was being done. Yep, so we see here he's getting he's creating the symmetric key, as you can see here. And he created this key in order to start encrypting the data, encrypting the resources rather. All right, that's for KMS. Now let's go ahead and check out the EC2. Now, for the EC2, the actual company had logs being created for the EC2 instance itself that the attacker was using to conduct some of his attacks. So we have logs of actual bash commands being ran. So let's go ahead and check them out and see what we can find in those commands. So let's go ahead and check out these EC2 logs. Now, they made a different index for these logs called admin test EC2 logs. So if we go ahead and search that as a query, we'll get the actual logs of the commands ran by the attacker. So as you can see here, he got he got root pretty quick just by running sudo su. And he conducted some enumeration. However, the most important or the most interesting portion of these logs is the fact that he synced this bucket right here. Huge logistic prod shipment. Now, after shipping it, he proceeded to download this wrapping public key.bin. And after that, he used OpenSSL in order to create a key and then encrypt it and then re-upload the encrypted version in the same bucket. So this is just another form of how he created his, or how he came about to create his ransomware attack and how he came about to lock the company out of more and more resources. Now let's go ahead and check the actual instance's actions, what the attacker did to the instance itself from outside of the instance. Now we're going to utilize a different query for this one. Let's go ahead and run this query, which tests for actions done on the EC2 instances by admin test. Now, as you can see here, he detached volumes, he ran instances, he created volumes, he terminated instances. So it seems like, and he did this quite a few times, and as well as creating snapshots. So it seems like what the attacker must have done is he stopped the instance, detached the volumes, possibly created a snapshot before continuing, and then re-encrypted those volumes using his own KMS key, and then reattached those encrypted volumes for the company and the team, the IT, to not have any access over those volumes without having access to his KMS key that he used. Crazy. Let's go ahead and confirm that he conducted destructive actions to these EBS volumes, the original EBS volumes, before moving forward. So as you can see, the event name that we're looking for is delete volume here. Bam. So looks like he deleted 4 different volumes. Now let's go ahead and check what he did to any S3 buckets. Okay, so looks like here he did the same sort of process for S3 buckets, where he got the bucket encryption to see the encryption that's being done on the bucket. For example, here on huge logistic backups, and then he put a new encryption on the bucket, probably using his own KMS key. Now let's go ahead and confirm that. Yeah, KMS North. Let's go ahead and confirm 8D89. So if we go back here, we see 8D89. It's the same KMS key that he created in order to conduct all of this ransomware. Wow. And how many buckets did he do this to? 1, huge logistic backups. 2, huge logistic warehouse docs prod. 3, huge logistic customer data dev. And it looks like that's it. 3 different buckets. Actually, one more right here. Huge logistic prod shipment. So 4 different buckets he locked out from the company, which he wants to use as ransom. Amazing. So with that being said, I hope that you enjoyed this video. These are the main areas of enumeration that you'll go through. However, if you wanted to dig deeper and explore for yourself, feel free to. It's a huge learning experience for you as a blue teamer to delve into this Splunk case, delve into this incident response case, possibly make a graph, make a timeline, make a table of all the information in the different categories of actions that the attacker conducted. Maybe get a remediation or response plan for how the company could remediate this or prevent this in the future from happening. Get as much experience as you can out of it. I hope you liked it and enjoyed it. If you did enjoy it, please leave a like and comment on this video, and let me know what you would like to see in the future. Thank you very much, and goodbye.